it should stop when a hurdle is in front of it. It means that whenever an object is detected by the sensor, it will just display a message on LCD that an object is being detected. Otherwise, no object detected, and the motor should stop on the object detection. The final step is the sensor motor driving system should also be connected to one controller. It means that all the driving parts of the motor and the sensor should be connected to the one part of microcontroller, and the communication system such as to display the object detection or no, or whether the object is detected or not, or and the other part that the temperature readings should be communicated via serial communication. It can be 12C or UART to the slave LCD. So that was our task, and we will proceed further. Routine we will write that whenever the pin is high, just send data to the slave through UART, and the slave will then display the characters that the object has been detected. And whenever the pin will be low, it will just send data there to the slave to display the characters that no object has been detected. So this was a simple work of we have displayed through using interrupts using a potentiometer. The next sensor was ADC sensor. Now ADC sensor we use a analog to digital converter of Arduino Mega, and we have set reference of 5 volt, and so whenever the input will be fed into the microcontroller, it will just calculate the data, storing it into its own bits such as ADCL, ADCH, and after that it will just send data through UART to the slave, and that would display it on the LCD that the temperature has the following temperature is here. And that was the work that we have to transfer from one microcontroller to other microcontroller. Now the other aspects of our line follower robot are the IR sensors, the robot, the motor driver. So for that purpose, we have connected three push buttons that will represent IR sensors. That is left sensor, and right sensor. Okay, so left, center, and right we have connected respectively to the left and right sensor to the port A pins, and the center sensor to the port J pin. And the inputs for the motor that are connected with here, that will decide that whether it should give the motor a high signal or low signal in order to turn the motor clockwise or anti-clockwise, or to control the motion of both motors. So these are the basic pins, and here actually the output is going to these motors from motor driver. So it works that if we here we have using three sensors. So if the left is one or the right is one, it means that a robot should turn left. So for the turning left, the right motor should turn on. This is the one criteria. The second criteria is the right sensor is one and the center sensor is one. This should analyze that the right sensor is activated, and for that purpose, the left motor should be turned on. And if three of these sensors are on one, it means all of these sensors are on black line, and both motors will turn off. So here we are applying a logic that when the sensor detects a black line, it gives the output 1, and when the sensor detects a surface, it detects output 0. So these codings are I have coded on these conditions. So that was all the purpose of our project. That how we can, and further we can also control the speed motor speed of PWM signals. PWM signals actually duty cycles. When we give a high duty cycle for a high, the motor will rotate in faster speed. Similarly, when we decrease the duty cycle to 75%, 85%, the motor will turn off for the longer period and will turn on for the shorter period. So we can just vary it for according to its desire, and for that purpose we would be using fast PWM mode. So that was what it from the circuit side. Now let's go to the codes. So that's our code for the logic defined earlier on Proteus. The first step we are defining our, you can see our CPU, that is 10 megahertz. Then the time delay library. Then we are including AVR interrupt for our ultrasonic sensor. to detect a change in its state of pin. The AVR library, and the one thing we have included here is double duty cycle. Now this duty cycle we will be using in PWM signals. Uh, these are the list of functions I have created because we want to call certain functions for the certain conditions. Left right for the motors, halt for the motor, forward for the motor, obstacle for the ultrasonic, path free. It's a command to send the data to the slave. We are using a path free function. For the initialization of for protocol, for UART we are using UART initialization, and send data from one for microcontroller to other. We are using a function of send data. Count, we will be using it in ADC sensor, and similarly character value of 10 will be using an itover function that is also using ADC sensor. If I go into much now, first of all, let's see how USART is being initialized and how we can send data through UART. Sorry, if we will go and into the functions. Yeah, here I created two functions. Here you can see wide use and UART initialization. We have actually UCS R not B 1x. It has actually 5 registers, in which one of the registers is UCS RB. In UCS RB, the bit TXE is actually good. It enables the transmission. That's why we are giving it a high logic. Similarly, in register UCS RC, these are two pins, UCS E00 and UCS E001. These are used to select the how many data we want to send. So as we have selected these two bits, we have selected the 8-bit data mode. For our to select the baud rate, we actually put the value in UBRR register, and it will just calculate the value on the formula. The formula will be UB baud rate is equal to FOSC divided by UBRR plus 1 multiplied by 16. So it will just put the value of UBRR and we will get the baud rate. And the further white send data unsigned character A, that's the argument we are passing in here, because the data we want to send here will be put in the argument, and that argument will assign to the UDR register. UDR register is actually handling the data that is being received or that is being transmitted. This condition is checking whether all the data has been transmitted or not, and using this UDRE 0 bit. That was the initialization part of the UART, and our further in the main function we have just called the UART initialization uh, because we want to initialize it in the upper part of the code, because we should initialize it earlier than at the last. Okay, DDRK support. DDRA is connected to sensor, DDRJ is connected to sensor, DDRH is connected to motor, DDRC is connected to I guess some sensor, and DDRE is we are giving it high and we are giving it low. Now DDRE is connected to UART. UART we have actually enabling the transmitter and giving zero logic to receiver. So it is a one-way communication from transmitter to receiver. And for D, we have now actually we are using interrupt. So for interrupt, we have to make for D pull up, making for D input pull up. ISC or a external interrupt control register, as we are using interrupt, so we have to enable these bits. And, to because it decides whether we are taking the logic change or the rising edge or the filing edge, that on the interrupt that should be called. So here I have chosen the bit I given high to the bit ISC00. That will do the fact that it will call the interrupts on any logic change. Okay, and IMSK, when we activate the external interrupt mask register into 0, now that pin would actually decide whether to call these rising, falling, or any logic change functions or not. If we are not selecting these register, not activating the int 0 pin in IMSK register, we cannot get close. We cannot access these function. We can say rising or falling edges, and we cannot get these interrupts on the specific conditions. Now this is a global interrupt in status register. We are calling uh, DDR actually 1 to 3 and 1 to 5. DDR is actually we're using our motor is connected to port H. So we are just giving as we're using PWM signals. So that's why we are actually controlling the bit 3 that will control the left side motor, and bit 5 that will control the right side motor, speed of motor. Now further to control the speed of motor, we are actually here selecting in TCC or not register. We are selecting our mode through these two pins WM0 WM01, and that will select the fast PWM mode and COM0A1 for our further compare our values to specific registers. TIMSK 1 to 2 is also setting interrupt enable and time mask register. Now the value we want to give duty cycle is actually stored in the OCR or not a register. That register actually compares the values to the specific desired value, and after that it will just fall to the ground. And so in this way we get a signal that is duty cycle. I mean, if we have selected this value to maximum, the signal will go to maximum, MNL will drop. If we selected this value to lowest, the signal will drop from a starting point. So for this purpose, we have set our P-scalar mode. These P-scalar mode are set in TCC are not being registered. And in TCC are not registered, we are selecting just our modes. Okay, and while in main duty cycle, we are actually implementing our duty cycle step by step. The first step, duty cycle will increment by 10%, and it will increment until it is greater than 100. After that is greater than 100, it will just initialize to 0. Now to actually again this value again that was given to its this one, we will call a interrupt service routine. That will be here. As you can see, ISR here. We have called interrupt service routine that will just initialize this value again to what we have given earlier. We can also change this value to get different duty cycles and with two motors. So after that, we are in the temperature sensor portion. In the temperature sensor, I have selected the reference value to 0. It was old one. Actually, I have selected the reference value to 0. And for if we select both the reference pins, reference F0 and reference S1, the temperature sensor will use the external A reference 5 volts. So for that purpose, I have connected to the ARF pin. And in ADCS-R register, we have turned on the bit ADN that selects that enables the ADC, ADIE, the internal interrupts, ADSP0, and these 3 bits. If we select the clock rate that we want our temperature sensor to communicate, so we have selected a clock rate of 128. And further in ADCS-R, ADSC bits for to start the conversion, and this is a flag that checks whether data has all been received or not. And after data has been received, we will clear the flag by giving it high, and the data will be stored in ADCL and ADCL. As it is a 16-bit register, we can only use 12 bits of it. So it is by default it is set as write shift. So in ADCL, we have just stored data, and after that we have prepared it through the formula to convert it into a the value that we can easily read. And we have used the function ITOA. ITOA is basically used to display the function parameters that are continuously changing. Here is the count we had just calculated through the formula that were stored in the ADCL and ADCS registers of ADC. Value that we have created array of 10, and here it is as 10 because we are using base 10. And if now here we are just calling our functions, we will go to later. Further, we will just see the functions here. This is a wide left turn. These are for the motor functions for the motors. If pin A is equal to 0 cross 0 1, so it is defined according to logic. I mean, if I had connected the pin A left and right sensor to the pin 1 and the pin 7 of sorry, the pin 0 and pin 7 of port A. So if the Now, if the left sensor was connected to bit 0 and the right sensor was connected to bit 7. So actually the bit 0 would be 1. If the left sensor is 1 and the right sensor will be 1, so it will say that turn the right motor on and turn all the left motors off. So in right turn, actually the right sensor will be turned on. So for the right sensor, the 7th bit will be turned on. So here written 8. The hexadecimal 8 number, if you convert into binary, we will get 1000. So that will eventually comes out to be 80. Now pin J is equal to 1. The center sensor will be always be 1. And for the right turn, we have to turn on the left motor. So here we have turned on the left motor, and the right sensor right motor will be turned off. Now, for the halt conditions, all our sensors should be 1. So, according to 8 is over 7 bit that is turned on, 1 is over 0 bit that is turned on, pin J is equal to 1 turned on. So, all our motors will be turned off. And forward, left and right sensor should be 0, and the center sensor should be 1, and our motors will be turning both clockwise. That was the line follower part for the simple. And if we can just go on here ISR timer effect, I described earlier these functions. And yes, now if 1 minute. Now I just said that we are using the ISR routine to display the data on a port if the pin was high at port D. Now to display data that the object is not there and you should move, the vehicle should move on. I just put here a condition that if the pin D is 0 and it is not high, then I collected an array that contains two characters G and O, and for loop for two characters. And if I have just called the function send data that I have created in the first step, and I have just passed it argument of array of 5. So that will just first of all send the data of G, and the data of G would go into the send data functions. And if we can see that the data G will be go there, and after that it will be sent out. After that the O will be sent out there and will go there. It will just send the data step by step. If, so that was from the ultrasonic part, the path 3 functions and initialization. So if in the last, I've actually called all these functions left and right and halt and forward for the motors, and send data of D. Now this data D is actually the unsigned character D is equal to value that is it will get in from the ADC temperature sensors, and this data will be we are placing it as an argument. That data D is also go into this function send data D, and data D will be sent on. So you actually send out all the data to the one from one microcontroller to other to UART. And here we have given a delay so that to avoid any mishaps, path tree and delay mishaps. So we call all the function ISR routine will be called on its own. That it needs not to be called on the main function. So that was it from the code side. Now let's see the simulation, how the simulation of ours works. Now here actually first of all we will turn off the pin, the no signal will go into the port 0 pin. So no ISR reading will be called, but instead we have created the function path free that will actually send the data if the pin is 0, and that will display in here go. We will see that will send data. And the one thing we have added here is the LCD library. Now if we will look into the LCD library, the one we are using is the 8-bit library in which we are using 8-bit communication mode. So the data pins in LCD data port C 0 to C would be used. Now these ports would can change according to our desires. These can be B, C, D. We will just have to change its name, and they will just have to change the names of control port A in PB0, something we want to change ourselves. These functions are to initialize the LCD to display the data that is coming through slave or master to the LCD, or to move the cursor from 0th position to 1 and in columns etc. And in wind LCD data to transmit the data coming from the master or slave, we have to uh, give high to the enable pin, because when the enable pin is high, it will actually start transmitting the data through the data ports. Otherwise, no data will be transferred. And LCD data string, we have made another function to display our characters one by one, whatever it's coming through the data. If we'll go into the main functions, we have just initialized both transmitter and receiver pin 0, because the transmitter is transmitting the information and we wanna give 0 to receiver, because to receive the information, because it is a one-way verification. DDRC is equal to 0 plus FF. These are the ports defined for the LCD. We have chosen the data rate of baud rate of the same baud rate that we have selected in transmitter, and after that we have just put in the value in the specific registers, UCS R naught B and UCS R naught C, to enable the receiver and to select our data. After that we have initialized our LCD, and then we are checking the condition whether our data received or not. And after that, when once the data is being received completely, it will store in the that variable that we have created of unsigned character type in UDR. And after that we will just display the after that we have just cleared the LCD using the command LCD slash cmd 0 and the data will the stored will be stored in the LCD data, and it will display the data that will be stored in the UDR register. And the cursor will move on to the sixth column, and with a delay of 1000 milliseconds the information will transfer one by one. And actually, the first of all we call the function of temperature sensor unsigned in transmitter part. So the first thing that will come in the data received data will be the temperature, and after that the data would be either the obstacle detected or not in the form of characters. So if you'll see in the simulation, let's see how it works. Now here if you will see the pin that we selected to port D was off, so the characters we should see here was go, and the temperature as it here is displaying 25 degrees Celsius. We should uh, get the data of 25 degrees Celsius here. So if we will run the simulation, we will see that the temperature is 25, and after that we will display whether the object is detected or not. So it is send a character of G, and after it will send a character of O. So so it was a part of this, and after the part of LCD, now let's see whether the motors work or not in the actual scenario. If I now if the left and the right and center, all the three sensors are on black line, and given the output of 1, the both motors should be turned off. Now if the left and the center sensors are on 1, it means the motor should turn left. For that, the right motor should rotate clockwise, and it will be 0. Now if you see, the right motor is rotating clockwise. Slowly and slowly it will increase to the maximum speed. And that was for the left turn. Now if we now the condition is changed. If the we can say that the left and right sensors are on 1, it means the motor should turn right, and for that the left motor should be turned on. Now we will see the left motor is turning on while the right motor is turning off. So that's the scenario how it will go. And if we want the both motors to work on, then the center sensor will be black line, it will be 1, and other two sensors will be 0. If I will just switch off, the motor will be start turning on. So that will be a forward conditions. So that's how our motors are working. The temperature sensor is being disconnected to the LCD, and interrupts, using interrupts we displayed the character go on the LCD. And so that was it. That was our task. Allah Hafiz. Assalamu alaikum. So here is a bit of modification I made it in my circuit. That was basically when I press the switch button, the signal will go into the microcontroller, and that will transfer information to the slave, and the data will display on the LCD. That if the switch is on, the character's halt will display on the LCD, and that will turn off all the motors, indicating that there is a hurdle in front of it. And when we turn on the switch, it will indicate that there is no obstacle in front of it, and the microcontroller will give signals to the slave, and that will display on the LCD that you can go, and the motors will start turning on instead of turning off. Now if we can see, the data is displaying go because the switch is off, no obstacle in front of it, and the motors will turn on and they will not turn off. So that's how the LDW modification to detect obstacle in front of it, and regarding the information the slave received from the master, it will display on the LCD, and also the master will turn on and off the motors, uh, analyzing that whether the object is in front of it or not. So that was a part of our code, and I modified it a little bit. So I think that was our task. Allah Hafiz.